Picture the final years of building Stonehenge, somewhere around 2500 BCE, a project that had likely occupied the attention and labor of multiple successive generations by the time its last stones were finally set in place. Generations of the same community, farmers descended from people who had lived across the British landscape for well over 1,000 years, hauling multi-ton stones across dozens of miles, aligning them with mathematical precision to track the solstice sun, finishing a monument that would still be standing 5,000 years later. Now picture what ancient DNA says happened almost immediately afterward, a finding that took even the researchers studying it by surprise. Within just a handful of generations, the population responsible for that achievement was almost entirely gone, not culturally transformed, not gradually absorbed, but genetically replaced by people who, as far as the evidence shows, had no meaningful ancestral connection to them at all. This isn't a dramatic exaggeration added for effect. It's close to the plain reading of one of the most startling findings in the history of ancient DNA research, published in 2018 by a team led by geneticist Inigo Olalde, examining hundreds of ancient genomes recovered from burial sites across Britain and continental Europe. The conclusion those genomes pointed to was almost too abrupt to believe. At first, the people who built Stonehenge left descendants who, within a remarkably short window of prehistoric time, made up only a small minority of the ancestry found in the population that came after them. To understand exactly how strange this finding is, it helps to first understand who the original builders actually were, and how completely embedded they seemed to be in the British landscape by the time this replacement occurred. The people responsible for Stonehenge and for the broader wave of megalithic monument building that swept across Atlantic Europe beginning around 6,000 years ago were farmers, descended from populations that had migrated into Europe from Anatolia thousands of years earlier, gradually spreading westward and mixing to varying degrees with the hunter-gatherer populations already living across the continent. By the time they were organizing the labor needed to drag bluestones 150 miles from Wales, or lining Newgrange's passage tomb with pinpoint precision to catch the winter solstice sunrise, these farming communities had been established in Britain and Ireland for well over 1,000 years, long enough to develop a distinctive, sophisticated, and clearly successful architectural tradition entirely their own. This wasn't a fragile, marginal population clinging to survival. It was a settled, organized society capable of directing enormous collective labor toward monuments meant to last for millennia. If you find it fascinating that a population this established, this successful, and this deeply rooted in a landscape could still be almost completely replaced within just a few centuries, that exact tension is what makes this discovery so unsettling and so important. Go ahead and hit that like button, because the genetic evidence behind this replacement is considerably more precise and considerably more dramatic than most people ever hear about. The population that arrived to replace them is associated with something archaeologists call the bell beaker phenomenon, named after a distinctive style of bell-shaped pottery found in graves across a huge swath of Europe beginning around 4,500 years ago. For a long time, archaeologists debated whether bell beaker culture spread primarily as an idea, a set of pottery styles and burial, customs adopted by existing populations through trade and cultural contact, or whether it spread because actual people migrated and settled in new regions, bringing their own ancestry along with them. The 2018 genetic study answered this question with a level of clarity that stunned even the researchers who conducted it. Examining ancient genomes recovered specifically from Britain, the study found that within a few hundred years of bell beaker culture's arrival, approximately 90% of the ancestry found in the British population had been replaced, not blended gradually across many centuries into a mixed population retaining meaningful continuity with what came before. Replaced almost entirely within a span of time that represents barely a handful of human generations, a genetic turnover so severe and so rapid that it stands as one of the most extreme population replacement events documented anywhere in the ancient DNA record. It's worth understanding exactly how researchers arrive at a specific figure like 90% ancestry replacement, since it's a considerably more precise claim than simply noticing that new pottery styles appeared in the archaeological record. Researchers compare the genomes of individuals buried before bell beaker culture's arrival against the genomes of individuals buried afterward, looking specifically at which ancestral populations: Anatolian farmer ancestry, earlier European hunter-gatherer ancestry, and steppe pastoralist ancestry contribute to each genome and in what proportion. By tracking how these specific ancestry proportions shift across a sequence of burials spanning several centuries, researchers can measure population turnover with remarkable statistical precision, distinguishing a genuine demographic replacement from a more modest genetic shift caused by ordinary intermarriage between two coexisting populations. When this method was applied to the British genomes specifically, the shift proved almost total within just a few generations, a result so stark that the research team reportedly double-checked their methodology extensively before publishing, given how dramatically it contradicted the prevailing assumption of gradual cultural continuity that had dominated British archaeology for decades. Let that sit for a moment, because the implications go well beyond a simple footnote about pottery styles changing. This means the descendants of the people who organized the extraordinary labor behind Stonehenge itself, who quarried and transported bluestones across 150 miles of ancient landscape, using nothing but timber, rope, and coordinated human effort, did not go on to become the primary ancestors of the people who occupied Britain afterward. A population arriving from continental Europe, carrying ancestry that had itself originated on the Pontic Caspian steppe far to the east, effectively became the dominant genetic forebears of nearly everyone who followed, practically overnight in archaeological terms. If uncovering the kind of quiet demographic earthquakes hiding directly inside ancient DNA fascinates you, make sure you're subscribed, because this exact pattern, populations vanishing almost completely within a few generations without any obvious archaeological warning sign, keeps surfacing across the genetic record of human prehistory. This raises an obvious and difficult question. What happened to the original population? Where did the descendants of the people who built Stonehenge actually go? Here, it's important to be precise about exactly what the genetic evidence can and cannot establish. Ancient DNA reveals the outcome with remarkable clarity, a rapid, overwhelming shift in whose ancestry dominates the population, living in a given place at a given time. It doesn't, on its own, reveal the specific mechanism behind that shift. Researchers studying this event have proposed several possibilities, none of them mutually exclusive and none of them fully confirmed by the genetic data alone. Disease is one leading candidate, since populations encountering unfamiliar pathogens carried by an arriving group can suffer catastrophic mortality, a pattern documented repeatedly in later, better recorded instances of population contact throughout history. Others point to lower relative fertility or survival rates among the earlier population, perhaps compounded by the social and economic disruption of encountering a new group with different metalworking technology, different subsistence strategies, and a fundamentally different approach to land use. Still others raise the more uncomfortable possibility of direct violence or displacement, though this remains considerably harder to confirm using genetic evidence alone, since a genome can tell you who left descendants and who didn't, but it cannot tell you exactly what happened in any specific encounter between two individuals 5,000 years ago. What nearly all researchers examining this evidence agree on, regardless of which specific mechanism they consider most likely, is that this wasn't a story of gradual, peaceful cultural blending. The genetic signal is simply too abrupt, too complete, and too consistent across multiple independent studies to be explained away as slow intermixing between two populations, gradually becoming one. Something disruptive happened in Britain around 4,500 years ago, and whatever it was, it left the genetic legacy of the island's original megalith building population as a small minority thread within just a handful of centuries. One additional demographic mechanism worth understanding, separate from disease or violence specifically, involves simple population mathematics, rather than any single dramatic event. Population modeling suggests the incoming beaker-associated population may have been considerably larger or growing considerably faster than the existing farming population it encountered, meaning that even without any catastrophic single episode, ordinary demographic momentum alone could gradually but rapidly overwhelm a smaller, more slowly growing population's genetic contribution across just a handful of generations. This process, sometimes called genetic swamping, doesn't require conquest or a single decisive event to produce a near-total ancestry replacement. It simply requires one population to have a substantially higher rate of successful reproduction than the other, sustained consistently across several generations, for the numerically smaller population's distinct genetic signature to become diluted to the point of near disappearance. Some researchers studying this specific case favor this kind of gradual demographic explanation over a single catastrophic cause, arguing that the genetic pattern observed in Britain is entirely consistent with sustained differential population growth, rather than requiring disease or violence as a necessary explanation at all. This same broad pattern, though not always quite as extreme, shows up across other parts of Western Europe during the same general period, as populations carrying this step-derived ancestry spread outward from Central Europe in multiple directions, associated first with the corded Ware cultural horizon, and then with the broader bell-beaker phenomenon that followed it. Iberia, Brittany, and Central Europe all show meaningful genetic shifts during the same general window, even though the specific scale and timing varies noticeably from one region to another. In Iberia specifically, genetic continuity with the earlier farming population remained considerably stronger than it did in Britain, even as beaker pottery and associated cultural practices spread widely across the peninsula. suggesting that in some regions this cultural package moved primarily through trade and adoption by existing populations, while in Britain specifically, it arrived alongside an overwhelming wave of actual new people. This regional variation matters because it rules out the simplest possible explanation, a single, uniform wave sweeping identically across the entire continent. What the evidence actually shows is something more complex and, in its own way, more genuinely unsettling. The scale of population replacement wasn't determined by the strength of the incoming cultural package alone. It appears to have depended heavily on local circumstances, population density, and the specific character of contact in each particular region, meaning the same broad migratory movement produced a near-total genetic replacement in one place, and a comparatively modest genetic shift in another, just a few hundred miles away. There's an intriguing wrinkle in the archaeological record worth addressing directly, because it complicates the picture of a clean, instantaneous replacement. Some megalithic sites, including certain stone circles and passage tombs, continue to be visited, used, and in some cases even modified for generations after this genetic turnover occurred, suggesting that whatever happened between these two populations wasn't necessarily a single, abrupt event, severing all connection to the past overnight, but rather a more layered process unfolding across several generations, during which older monuments apparently retained at least some symbolic or practical significance even to the newly arrived population. This raises a genuinely open question researchers are still actively working through. Did the incoming Beaker-associated population simply repurpose sacred sites they encountered, adopting monuments built by people they had largely displaced without necessarily understanding or preserving their original meaning? Or does this continued use suggest a somewhat less abrupt cultural transition than the stark genetic ancestry data alone might otherwise imply? Resolving this fully will likely require combining ancient DNA evidence with much finer-grained archaeological dating of specific activity layers at individual sites, work that continues today, site by site, monument by monument, gradually filling in the details of exactly how this transition actually unfolded on the ground. There's a particularly striking detail connected to the earlier, replaced population worth sitting with here, one that deepens exactly how thoroughly this no-connection framing holds up. A 2020 genetic study examining remains recovered from inside Newgrange, the same 5,000-year-old passage tomb whose entrance is aligned precisely with the winter solstice sunrise, identified a man whose parents were, according to his own genome, either siblings or a parent and child, first-degree incest of the kind historically, associated almost exclusively with royal or divine dynasties attempting to preserve an exceptional bloodline. This detail matters enormously for understanding exactly what was lost. The society that built Newgrange wasn't simply an anonymous population of farmers. It appears to have included a genuinely dynastic ruling elite, powerful and convinced enough of its own extraordinary status to practice the kind of extreme intermarriage typically reserved for populations who believe themselves touched by something divine. That entire social structure, along with whatever specific religious or dynastic beliefs justified it, disappeared along with the genetic lineage that produced it, leaving behind only the stone monument itself as a silent physical remnant of a society that otherwise vanished almost without a trace. It's worth being clear about what no connection does and doesn't mean here, since it's tempting to read this framing more absolutely than the genetic evidence strictly supports. The incoming Bell-Beaker-associated population wasn't entirely unrelated to the earlier farmers in the deepest possible sense. Both ultimately descend from the same broader human migrations that populated Europe over the preceding tens of thousands of years. What no connection refers to specifically is the complete absence of meaningful direct genetic continuity between the specific population that built these monuments and the specific population that occupied the same landscape immediately afterward, a genuinely severed thread at the regional and generational level. Even though both populations ultimately trace back to shared, much deeper human ancestry, if you go back far enough in time. This distinction matters for how we should think about identity tied to place versus identity tied to direct genetic descent. People living near Stonehenge today rightfully claim it as an important piece of shared cultural and national heritage, a monument built on the same land their communities have occupied for thousands of years. But according to the genetic record, the population responsible for actually conceiving, organizing, and constructing that monument is connected to the population living in that same location today by a considerably more distant and diluted genetic thread than most people would ever assume without this evidence. The stones remain exactly where they were placed 5,000 years ago. The bloodline of the people who placed them followed a far more discontinuous, more abruptly interrupted path than the landscape itself would ever suggest on its own. This pattern also invites a broader comparison to other instances of dramatic ancestry turnover documented elsewhere in the ancient DNA record, since Bell Beaker Britain isn't an entirely isolated case within the broader history of European prehistory. Similar, though not always quite as extreme, replacement events have been identified at other points and in other regions across the ancient genetic record, suggesting that severe rapid ancestry turnover following the arrival of a new population may have been a or settlement patterns, particularly if the incoming population adopts, at least temporarily, elements of the material culture they encountered upon arrival. This means the true frequency of dramatic population. Replacement events throughout human prehistory likely remains considerably underestimated even today, with ancient DNA research continuing to reveal additional cases. As researchers apply this same comparative genetic methodology to burial sites in other regions and other time periods that haven't yet received the same level of detailed genetic scrutiny that Bronze Age Britain has now received. There's a broader lesson embedded in this discovery that extends well beyond Stonehenge and Bell Beaker Britain, specifically. Archaeology working without direct genetic evidence has always had to rely on indirect signals, pottery styles, tool traditions, burial customs, and settlement patterns to reconstruct population history. These signals are genuinely useful, but they cannot detect a population replacement the way genome sequencing now can. A newly arrived population can easily adapt, or even preserve existing pottery styles, burial customs, and land use patterns while still representing an almost entirely different genetic lineage than the people who came before them. This is precisely why the old continuity assumption persisted for so long. It wasn't sloppy science. It was simply a genuine blind spot that no methodology available before direct genetic sequencing could have realistically closed. So the next time you see Stonehenge or Newgrange or any of the extraordinary megalithic monuments scattered across Atlantic Europe, it's worth holding two facts in mind at once, facts that sit somewhat uncomfortably alongside each other. The stones themselves have endured, weathering 5,000 years of wind, rain, and changing landscape, standing today essentially unchanged from the moment their builders finished raising them. But the population responsible for that achievement, the specific farmers, engineers, and apparently dynastic elite who conceived of and organized these monuments was, within a few short centuries of finishing their work, almost entirely replaced by strangers arriving from far across the continent, carrying no meaningful direct genetic connection to the people whose achievement they were, in effect, inheriting. Stone remembers in ways that bloodlines simply do not. And nowhere is that harder truth more clearly written than in the quiet, persistent gap between who built these monuments and who actually descended from them,